Under most conditions, a modern brake system is more than adequate to handle the demands of the driver to bring the vehicle to a safe stop. Under some situations, the brakes of one wheel may lock up, causing a loss of braking efficiency, longer stopping distances, and negatively affect steering and handling during braking. Under the conditions of wheel lockup, a skilled driver can regain control of the braking system by pumping the brakes to release and reapply the brakes, thereby freeing the wheel from the lockup condition. The primary function of the ABS system is to accomplish the same objective of preventing wheel lockup as manually pumping the brakes does on a non-ABS vehicle. Alleviating a wheel lockup condition will reduce stopping distances while restoring directional stability and directional control. It is important to remember that the anti-lock brakes cannot compensate for poorly maintained brakes, incorrect front-end alignment, worn tires, or driving a vehicle in an unsafe manner. The microprocessor in the ABS system is often referred to as an ECU, or Electronic Control Unit, because it processes electronic input signals and reacts by controlling output signals to the ABS actuator when the input signals indicate a wheel lockup condition. The ECU contains a microprocessor known as a CPU, or Central Processing Unit, that is of the CMOS design. CMOS means that the CPU is a complementary metal oxide semiconductor, commonly known as a computer chip. The CPU processes input from various sensors and switches, as well as other electronic control units, to determine if ABS should be activated. The wheel sensors generate an analog signal as a toothed wheel passes a magnetic signal generator. As those signals are received by the ECU, they enter an analog to digital converter that turns the analog signal into a series of digital pulses. Once converted from analog signals, the digital signals pass through a series of logic gates. A logic gate is a switch that will route the electrical pulses to either of two paths, depending on the value of the signal. If the signal is within the normal range of operation, it means that the wheel is rotating freely and no ABS action is required. If the signal is below the normal range of operation, it means that the wheel is locking up. The CPU will enable ABS for when this situation occurs. There are 4 separate wheel sensors on most ABS systems, one for each wheel. When ABS is required, it is only applied to the wheel that is locking up. If 2 rear wheels share a common ABS channel, the ABS will be enabled for both rear wheels, even though only one is locking up. The role of the CPU is to process the signals it receives from each of the wheel sensors, consider them in terms of the general vehicle operating conditions, and then take the appropriate action. The CPU executes a program or set of fixed instructions to compare the values of the signals. The program resides in the firmware of the microprocessor, also known as read-only memory, or ROM. If during braking or not, all of the wheel sensor signals indicate readings in the normal range of operation, the CPU does nothing. ABS is not applied and remains at rest. If during braking one of the values is below the minimum value for normal operation, the CPU determines the wheel is locking up and applies the ABS to that wheel. Some ABS units also include a traction control function. If under any condition other than braking, one of the wheel sensor values indicates the value is above the normal values, the CPU determines the wheel is losing traction. On traction control ABS systems, the CPU will initiate a routine to apply the brakes of the wheel that is spinning too fast to slow the wheel down. This restores traction and brings the wheel sensor value back into the normal range of operation. Keep in mind that the wheel speed varies greatly with road speed. The CPU program must take the speed of the vehicle into account to determine the normal range of the wheel speed sensor signals. The vehicle speed is input through the vehicle speed sensor. Data on speed of the vehicle as well as data on other key operating conditions are sent to the ABS control unit through a network of wires that relay information from the engine control module or powertrain control module, whichever is used on that vehicle to monitor engine and transmission operation.